After you understand your linear equations, there are linear equations in two variables. Now let's say, for example, you have two unknowns. You're buying pens and pencils. The cost will be different, right? So let's say the number of pens is X, the number of pencils you're buying is Y. So one scenario is you have to buy a total of 30 pens and pencils. If you have that scenario, you can always convert any such scenarios into a mathematical statement that becomes an equation where you'll say that number of pens plus number of pencils has to be equal to 30. Okay? And now what we are doing is, because we have two variables here, you really cannot solve the two variables with one equation. Why? Because there will be too many options. You can buy 29 pens and one pencil. Likewise, you can buy 15 pens, 15 pencils. There will be infinitely many answers like this. There will be many options. So when you have two variables, you exactly want two equations to solve together. This is called solving simultaneous equations. The word simultaneous means together, like at the same time. So at the same time, you will have to have another scenario that will satisfy this condition. Okay, this is the second part of algebra where you talk about solving for two variables together. So remember, you cannot solve by using just one equation. You need two equations to solve for two unknowns. Apart from this, they'll tell you one more information. That is, if the cost of pens is $5, okay, one pen cost you $5 and one pencil cost you $3. And now the total amount you are spending will be your next condition. This is a similar approach, or this is the kind of what problem they'll ask you during your exam. So they'll tell you the cost of a pen is $5 while the cost of a pencil is $3. You'll be spending a total of $110. This is a scenario they'll give you. Okay, so you're spending a total of $110 buying the two items, and you know the cost of two items individually. Okay, so now you have two scenarios. You know the total amount or the total number of pens and pencils you're buying, and you also know the total cost that you are paying for buying the pens and pencils together. So now, because you have two scenarios, you want to solve the two equations together. How to solve it? There are various ways. So the first simple way of solving the equation would be, as we call it, as substitution method. Meaning you can substitute what one variable is with respect to another and then use the other equation. So I'm going to show you how that works. If I know that x plus y is 30, I can say that the number of pens alone will simply be 30 minus the number of pencils. So when you know this, when you got an equation where you have connected the number of pens with the number of pencils, you can plug this right into the other equation to solve them together. Let's see what happens. Because I have got that x can be written as 30 minus y, 30 minus the number of pencils. I'll plug it here 5 times. 30 minus y plus 3y should be equal to 110. Now what happens? Because I have the number of pens I have now is 30 minus y. I know the cost of one pen is 5. So I'll just do 5 times 30 minus y. You have to open up the brackets. This is called distributive property, where the value outside is supposed to be considered and multiplied with both the values inside. So 5 times 30, it's just 150. 5 times y is 5y. Because there was a negative sign, I would carry that sign as it is. Plus 3y should be equal to 110. And now you have the like terms. If you'll notice this, now this becomes an equation only where there is one variable to deal with. So this is when your equation has been converted into linear equation in one variable. You can find that variable now. How will you do it? 150 minus 5y. Minus 5y plus 3y is same as solving for minus 5 plus 3 and then plugging in that y as it is. So minus 5 plus 3 is minus 2. So I'll write that as minus 2y equals to 110. When you see a scenario like this, a lot of my students, they just go and subtract the numbers that they see. But the problem is, you clearly see the variable part or the variable term is negative here. So my suggestion is, if you see that the variable term is being multiplied to a negative number, you might want to solve this by looking at the other term, 150. Because it's being subtracted from 150, I can take this 150, I can subtract this 150 both sides. And maybe if I'll do that, if I'll subtract 150 from both both sides. Both sides as in you have an equation equal to, so you have two sides, the left hand and the right hand. That is where you'll bring 150 here to subtract. If you'll do that, 150 minus 150 is 0, so you just have that term gone. Minus 2y remains as it is, and 110 minus 150. The answer is minus 40. And now you clearly see you have that negative term both sides. When you clearly see minus minus both sides, you actually cancel them easily. Why? Because it's the same. You're comparing the terms alone, and that minus is present on both sides. You can just get rid of it because you just want to deal with this value. Now 2 times y is 40. To find the value of y, it's just like going backward again. 2 is multiplying y. So to find y, I will have to divide by y, which is just as opposite of multiplying. So if I'll divide by 2 like this, both sides, then what you have is simply 40 divided by 2. The answer is 20. So y equals to 20. What was y? It was the number of pencils. Okay, I got the number of pencils as 20. So what should be the number of pens? Remember, we had used this statement to solve for the number of pens. I know that number of pens is simply equal to 30 minus y. So I'll just plug it here. X equals to 30 minus y. And because I got the value y as 20, I'll plug it here, and simply the answer becomes x equals to 10. Which means you are actually buying 10 pens and 20 pencils. So you see, when you have two scenarios, you can actually solve them together and you find the value of two variables. This is the second concept of linear equations. We call it as solving simultaneous linear equations.